Hello everyone. In this video we are going to talk about resistance, cause of resistance, factors affecting resistance, and we are going to solve some question on resistance. So in order to know resistance we should know Ohm's law first. So Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across its end. So V is proportional to I, and if you change this proportional sign with equal to, we'll have to put one constant, that is R. So V is equal to IR, and this R, which is a constant, is called the resistance. Now let's see what is the definition of resistance. So from this picture we can see that potential difference will try to push the current and resistance is trying to stop the current. So resistance is nothing but the property of a conductor to oppose the flow of current. So now let's see the cause of current, from cause of resistance, from where the resistance is coming. So as we all know, the flow of charge inside the conductor is current. So electrons are flowing inside the conductor. We expect electrons are flowing this way straight, but in reality they are not moving this way because the atoms are present, so they cannot move straight, they cannot move freely, so they have to follow the zigzag path, and while moving they collide with this atom, and this collision makes it difficult to flow of charge, so that's why the resistance will come. So you can see the cause of resistance is collision between electrons and atoms. So you can pause the video and copy the cause. So next we are going to talk about the factors affecting the resistance. In order to know the factors, let's consider this four roads, and from this four roads cars are moving. So if more car can cross the road, we say less resistance. If less car is flowing through the road, we say more resistance. So let's compare these roads. So first I'm comparing the two roads. So the cars are moving randomly, so at the end you can see only two car has crossed the longer road. So that means if the roads are long, it will give more resistance. So more the length, more the resistance. So in second case, if you compare the same road with the broader road, so you can see more car can cross this road at the same time. So if you increase the area, the resistance will become less. So out here the resistance is less, so I can say resistance is inversely proportional to the area. So in third case, as you can see, the condition of road is not good, so it will offer more resistance. See, in first case 3 car has crossed, and in second case only 1 car has crossed. So I can say more resistance because the resistance depends on the nature of road or nature of conductor. Now from this activity we have come to know that resistance depends on length, resistance depends on cross section area, and the nature of the material. So we have taken the previous idea to know how the resistance of a conductor changes. So these are the factors. You can pause the video and copy the factors. Okay, now let's get the formula for resistance from the previous activity. As we already know, resistance is proportional to length, resistance is inversely proportional to the cross section area. Then on combining above two, I'll get R proportional L by A. Now if you want to remove this proportionality sign, then you'll put a constant. So I'll write R is equal to rho L by A, and this rho is a constant and it is called resistivity, and the resistivity of conductor never changes. Okay, it's constant, that's why I'm saying it's a constant for a conductor. Now let's use this formula to calculate the resistance of a conductor. So now this is a question. Length of a conductor is made 5 times its original length, keeping the area of cross section constant. Calculate its new resistance. So what I'm doing is, I'm having one resistance, I'm making its length 5 times, but I'm not changing the area, I'm just adding the thing. So how the resistance changes? So as we already know, with length the resistance increases. So in this question, resistance will increase. Now let's see what happens. So first, I'm assuming length is L and A is area for our conductor. So and rho is the resistivity. So I can write resistance is equal to rho L by A, which is the formula we have derived in previous page. Okay, so now this is the resistance, original resistance. Now what are the things which are given? I'm changing the length and making it 5 times. So my new length, I'm denoting it by L dash, is 5 times the original length. It's saying 5 times the original length, and new area is same as old area, as we are not changing the area, so it's written in the question also. So my new resistance, which I denote by R dash, so to make it new, because it will be confused with old R, so I'm writing R dash. R is old resistance, R dash is new resistance, is rho. As I have said, rho, the resistivity never changes, so new resistance is rho times new length by new area. So now I'll put the values now. So see, R dash is equal to rho, I'm keeping it that way only. So instead of L dash, I'm putting 5L, because L dash is 5L, and instead of A dash, I'm putting A, because I'm not changing the area. So I'll take this 5 out and I'll keep everything else in the bracket. So if you see, you'll get 5 rho L by A, and whatever is inside the bracket can be replaced by R, because rho L by A is R. So I'm writing 5R. So as you can see, now R dash has become 5R. So your new resistance is 5 times the old resistance, that is R. So from this I can conclude that the resistance become 5 times the original resistance. So this is the same thing I've done in one page. You can pause the video and copy, and if you have not understood anything, you can go back and check what are the things I've done. So similarly, I've given this question which is similar to the previous question. You can try. In some of the question I've changed the area, in some of the question I've changed the both, so you have to take care of this. Read the question properly and do this question. And now there is another kind of question in which I'm stretching the wire. In previous question I've not stretched, I've just added the length. Now in this question I'm stretching the conductor. So it's say I'm stretching the conductor to make its length 3 times the original length. So in this question the area will also change. Now let's see. So I have a conductor, I'm stretching it to make its length 3 times. So now let's see how the resistance will change. Okay, so as previous question, I'm assuming length to be L, area to be A, and resistivity to be rho. So from this I can write resistance is rho L by A. Now what are the things which are given? So first thing given is I'm making the length, new length 3 times the old length. So L dash is 3L, and the area, now as I have said, area will also change because I'm stretching it. So I have to find the new area. So in order to find new area, I have to make use of this formula. So when you stretch the wire, its volume will remain same. So original volume is equal to new volume. So formula for volume is area into length. So area into length is equal to new area into new length. So I can write A dash is equal to AL by this L dash will go down. So now I'll put the value of L dash from here, that is 3L. So AL by, instead of L dash I'll write 3L, and I'll cancel 2L. So I got A by 3. So your new area A dash is A by 3. Now you got the value of A dash also. Now we can use the formula. So new resistance, that is R dash is equal to rho L dash by A dash, and I'm writing that dash to denote the new things, okay, so that I don't get confused with this formula. So new resistance, that is R dash, is rho L dash by A dash. Now let's put the values of L dash and A dash. So what is the value of L dash? That is 3L. So I'm putting, instead of L, I'm putting 3L. So instead of A, I'm putting A by 3. So now I'll solve this. This 3 will go up and it will become 3 into 3 L by A. So now when you multiply this to 3, you'll get 9, and inside the bracket rho L by A. But we know rho L by A is our old resistance from here. So I can write 9 instead of rho L by A, I'll write R. So I got R dash is equal to 9R. So your new resistance becomes 9 times the original resistance. So this is how we solve this question. So this is, again, you can pause the video and copy this, and I've given some question in next page. You can try this question. So in this question I have changed the length, it is same as previous question, and in this I have changed the cross section area. So please try this question. Thank you.